Hello everyone and welcome to our today's class. It is our third lesson on the topic Electrostatics 1. So let me commence by giving you the quote of the day, which states that never trust a person who treats you well but mistreats or disrespects either a watchman or a waiter. So we'll discuss that quote at the end of our class today. So today we'll be looking at the electroscope. We'll be looking at the electroscope. So to understand it, we'll look at what we call a gold leaf electroscope. But we need to understand first what we mean by an electroscope. So an electroscope, this is an instrument which works on the principle of electrostatic charges. It is used for investigating the effect of electric charges. Now this is a common gold leaf electroscope. Remember we have other electroscope which are made of where the leaf is aluminium. So in that case we'll call that aluminium leaf electroscope. But here we are looking at a gold leaf electroscope. So gold leaf because the leaf is actually golden, or it is made up of gold. So we need to know several features and their functions of a gold leaf electroscope. So here we have the brass cap, we have an insulator here, we have the earth connection, we have the metal plate, the gold leaf, and the glass window. Now what are the functions of each and every of these parts? So the gold leaf electroscope consists of a thin gold or aluminium leaf on the plate connected to a metal rod that has a brass cap at the top. So this is what we are calling a thin golden leaf, which is connected to a metal rod with a brass cap at the top. So let's look at the functions of each feature. So here let's start with the brass cap, or simply the cap. So the cap, its function is it acquires the charges through induction or contact that and spreads it through the rod to the plate and the leaf. So the function of the brass cap or the cap is simply to acquire the charge through the method of induction or contact and spread it through the rod to the plate and to the leaf. So it simply acquires the charges and spreads them through the metal rod to the metal plate and the golden leaf. Now why is it circular? So the cap, as you can see here, it is actually circular. So the cap is circular to ensure that there is uniform distribution of charges on it. So the cap is circular to ensure uniform distribution of charges on it. Then both the plate and the leaf shows the presence of charges by repelling each other, making the leaf to diverge. So the function of the plate, that is this what we are calling the metal plate, and the leaf is just to detect or show the presence of charges by repelling or attracting each other, making the leaf to diverge. So the plate, that is the metal plate and the leaf, the metal plate and the golden leaf, its function is to detect the presence of charges by repelling each other, making the leaf to diverge. Then the presence of charges is also shown when the leaf divergence decreases. So when the absence of charges, when there are no charges on the electroscope or on the cap, the golden leaf will be observed to reduce its divergence, or it converges to some extent. So when there is absence of charges, the divergence reduces. When there is presence of charges, the divergence increases because of the repulsion. Remember, like charges will always repel each other. Then the metal casing is for protecting the leaf from effects of drought. This is what we are calling the metal casing. This is the outer part. So its function is simply to protect the leaf from the effects of drought. Then the casing has a glass window. This is what we are calling the glass window. So the glass window, its function is actually the glass window simply ensures that we are saying that the metal rod is actually the metal casing is for protecting the leaf from the effects of drought, whereas the casing, that is the glass casing, has a glass window through which observations are made. So it is actually transparent. So its function is to allow observations to be made. That's about the divergence, increase or reduction in the divergence of the leaf. Then we also have what we call the rod, that is our metal rod here. So the rod is supported by passing it through a plug or a good insulating material such as a rubber. Now remember, an insulator does not allow flow of charges, so the insulator simply stops charges given to the cap from spreading onto the case and leaking away. So the insulator simply ensures that there is no leakage of the charges from the brass cap and even from the metal plate. Then the casing may have a terminal connected to the earth, which is labeled E. So this is what we are calling the earth connection. So remember, we defined earthing as the process of losing charges to or gaining charges from the earth through a conductor. So the earthing simply ensures that the excess charges flows to or from the surface, from the earth surface. So those are the basic features of a gold leaf electroscope. So you can be asked to label the parts. You need to know all the parts and their respective functions. We also look at the methods of charging an electroscope. Now basically we have two methods of charging an electroscope. One, an electroscope can be charged by either contact method, or two, by induction method. So remember, contact means that our polythene rod, or the rod, whether it is positive or negatively charged, it has to be in contact, or it has to touch the brass cap. So here we are demonstrating charging of a conductor of an electroscope negatively, of course using a polythene rod. It is important to remember that when an electroscope is charged by contact method, it acquires similar charges to that of the charging rod. So the procedure involved is that you first charge a polythene rod by rubbing it with a clean dry duster. Then roll the charged rod over the brass cap of the electroscope and subsequently withdraw it. So you first charge the polythene rod, of course negatively, then you roll it over the brass cap. Remember, contact method, the rod, that is the polythene rod, has to be in contact with the brass cap. Now remember, initially the brass cap is neutral. Remember, we said that a substance is neutral if the number of negative charges and positive charges are neutralizing each other, or are the same. For example, assuming initially the brass cap had 4 positive charges and also 4 negative charges, so it means the net charge on that brass cap, that is the initial one, was actually 0, because 4 electrons or 4 negative charges cancels 4 positive charges. So initially the brass cap was actually neutral. But when a negatively charged polythene rod is rolled onto the brass cap, the negative charges, because like charges will always repel each other, the negative charges that were on the brass cap, they are repelled downward. So when they repel, they actually come on what we call the metal plate here and on the golden leaf. So it means upwards only positive charges will remain there, because unlike charges will always attract each other. So the negatively charged polythene rod attracts the positive charges and neutralizes them. So the 3 or the 4 negative charges of the negatively charged polythene rod neutralizes the 4 positive charges on the brass cap, whereas the negative charges that were on the brass cap, they are repelled downward. So when they are repelled, they actually come onto the metal plate and onto the golden leaf. So it means the positive charges have been neutralized. Therefore it means that the brass cap remains negatively charged. So we are saying that you charge a polythene rod by rubbing it with a clean dry duster, then you roll the charged rod over the brass cap of the electroscope and subsequently withdraw it. So the negatively charged polythene rod repels the negative charges which spread onto the plate and the leaf. So the negative charges are repelled onto the plate and the leaf. That is, they are repelled, therefore they move downwards. Then repulsion between the plate and the leaf occurs and the leaf divergence increases. Why does the leaf divergence increases? Because these are like charges, that is negative and negative, so they will always repel each other. So the repulsion is what causes the leaf divergence to actually increase. Then when the process is repeated several times with the negatively charged polythene rod, the leaf divergence increases to the maximum. That is, whenever the charges are many, it means the divergence of the leaf will also be maximum. Therefore, we say that the electroscope is said to be charged negatively by contact method. Remember, in contact method, the polythene rod has to be in contact, or it has to touch or to be rolled onto the brass cap. Then the electroscope can also be charged. That is, it can also be discharged after it has been charged. So the electroscope can also be discharged by touching the brass cap with a finger. So remember, when you touch the brass cap with a finger, your finger is actually connected onto the earth surface. So it means the electrons will flow from the brass cap onto the earth surface, thereby discharging the electroscope. Then the electroscope can also be charged positively through the same process by using a different charging material, e.g. a glass rolled with a clean dry silk cloth. Now remember, a glass rod is used to obtain positive charges. So that means if you want to charge it positively, so in this case the electrons are attracted from the cap to the rod, they neutralize the rod, and the electroscope becomes positively charged. So if you wanted to charge the same electroscope but positively, you will now use a glass rod. Remember, a glass rod is positively charged. So when a glass rod is rolled onto the brass cap, remember initially we said that the brass cap is neutral. That is, it has both positive and negative charges. So when you bring a positively charged glass rod and roll it onto the brass cap, because it is positively charged, positive charges will be repelled downwards, meaning the leaf will have the positive charges, whereas the negative charges will be neutralized by the positive charges on the glass rod. So when the glass rod is withdrawn, it means the electroscope will remain being positively charged. So we said that it is important for a student to know that when you are charging a material by contact method, that is, the electroscope acquires charges that are similar to the charges of the charging rod. So in contact method, the charged material coming into contact with the cap of the electroscope is an insulator. Only the charges on the rod's surface coming into contact with the cap are used in neutralizing the charges induced on the cap. So that is basically how to charge a material or an electroscope by contact method. So you just bring a negatively charged rod, then you roll it on the brass cap. Remember, we said the brass cap is initially neutral, so the negative charges of the brass cap are repelled downwards, then they go onto the metal plate and also the leaf, whereas the positive charges that remain upwards, they are attracted and neutralized by the negative charges on the rod. Then when the rod is withdrawn, actually the divergence of the leaf increases because of the repulsion of the charges on the golden leaf and the charges on the metal plate, because remember, like charges will always repel each other. So we look at charging an electroscope by induction method. So remember, the only difference between induction and contact method is that in induction method, the rod should not touch. It is only brought close to the brass cap but does not touch the brass cap. Then when a material or an electroscope is charged by induction method, it acquires charges opposite to that of the charging rod. That is, like for this case, this is negatively charged, the rod is negatively charged, but our final electroscope is positively charged. So it acquires charges opposite to that of the charging rod. So here the apparatus required, of course, we need a gold leaf electroscope, we need a polythene rod, then a woolen cloth. So the procedure followed in this method is that first you touch the cap of the gold leaf electroscope with your finger to ensure that it is fully discharged. Why? Because your finger is connected to the earth, therefore the electrons can flow through your body to or from the surface of the earth. Then you bring a charged polythene rod close to the cap of the uncharged electroscope, but it should not touch because this is induction method. Then you observe what happens. While the rod remains in its position, touch the cap and note again what happens to the leaf. Then finally, withdraw your finger and subsequently remove the polythene rod. You again note what happens. Now, when the charged polythene rod is brought close to the cap but not touching, the leaf rises. The question is why? So when you bring a charged polythene rod that is close to the cap but not touching, the leaf divergence increases, or the leaf rises. Why? Remember, initially the cup is neutral. That is, it has equal number of positive and negative charges. So whenever you bring a negatively charged rod close but not touching the cup, the negative charges on the actually polythene rod will repel the negative charges on the cup. When the charges are repelled, they move downwards. So the plate becomes negatively charged, and also the golden leaf becomes negatively charged, because negative charges or like charges repel each other. So the repulsion between the negatively charged plate and the negatively charged actually leaf of the electroscope, the repulsion is what causes an increase in what? Divergence of the leaf. So we are saying that when the charged polythene rod is brought close to the cup, the leaf divergence increases. Now when the cup is touched while the rod is still in position, the leaf divergence decreases. The leaf divergence decreases. We will see why. When the earth connection is removed, by removing the finger and the polythene rod subsequently withdrawn, the leaf diverges. Now the question is why? When the charged polythene rod is brought close to the cup, electrons are repelled to the plate and to the leaf, making the leaf diverge. So we have said that when you bring a negatively charged polythene rod close to the cup but not touching it, the electrons on the cup are repelled downwards, therefore they come on the leaf, because they come on the plate and the leaf. So because like charges repel each other, that what causes an increase in divergence. That is what causes an increase in divergence. Then when the cup is touched, remember when you touch your earthing, the negative charges or the electrons flow to the earth through the body. Now when you come and touch this cup with your finger, the electrons on the leaf actually flow to the earth. Now when they flow to the earth, it means you have reduced the number of charges on the leaf and the metal plate. So because of the reduction of the leaf, it means also the divergence reduces, because you have reduced the charges. That is, this demonstrates when you have touched the cup with your finger such that the electrons flow onto the surface of the earth through a process called earthing. So because of the reduction of the electrons onto the leaf and the plate, that is what causes reduction in what? Divergence of the leaf. So we are saying that when the cup is touched, the negative charges of the electrons flow to the earth through the body. Now when the earth connection is broken or is broken by removing the finger, the polythene rod withdrawn, the positive charge which was attracted to the cup redistributes into the plate and the leaf. Now remember, earthing, we earth while we are still holding the glass rod, the polythene rod in position. So after all the electrons has flown onto the surface of the earth, it means now the brass cup and the metal rod has only remained with positive charges. However, positive charges are still on the upper side of the cup because they are being attracted by the negatively charged polythene rod. Now, after all the electrons has flown and you have removed your finger, then you remove the metal, the polythene rod. Now, when the polythene rod is removed, remember the positive charges were held up here by the negatively charged polythene rod. So it means when you remove the negatively charged polythene rod, the charges actually redistribute. So initially they were on the cup, but when you remove the polythene rod, they redistribute back onto the metal plate and even onto the leaf. So because this is positive and this is positive, the leaf divergence increases because positive charges will always repel each other, or like charges will always repel each other. So we are saying that when the earth connection is broken by removing the finger and the polythene rod withdrawn, the positive charge which was attracted to the cup redistributes because of the repulsion into the plate and the leaf. So the leaf as a result diverges and the electroscope becomes positively charged. So the electroscope can also be charged negatively in the same way, but using a positively charged rod. So if you want to charge an electroscope negatively but by an induction method, you use a positively charged glass rod. So when a positively charged glass rod is brought close to the cup but not touching it, now in that case it means the positive charges will be repelled downwards while the cup will remain with negative charges. After the positive have been repelled downwards, you now earth it or you touch with your finger. Now when you touch, the earth will supply you with electrons of equal number to the electrons that are actually are on the brass cap. So when those electrons, when those positive charges, we've said that when you bring a positively charged rod, the positive charges will attract electrons up here, and the positive charges will be repelled downwards. Then after that, you earth it. When you connect your finger, the earth, remember the electrons will be up here, so those electrons remain up, while the positive charges that were on the leaves will actually, the earth will supply you with equal number of electrons to neutralize the positive charges on the leaf. Now when the positive charges are actually neutralized, or when they are earthed, it means that the electroscope will only remain with negative charges. When you remove the glass rod, that is, which is positively charged, they redistribute, and the electroscope is said to be negatively charged. That is in that case. We also look at several uses of an electroscope. What are the functions of an electroscope, or where do we use an electroscope? So the first use is that an electroscope is used to detect the presence of charge on a body. It detects whether a body is charged or not. So the material to be tested is placed on a brass cap close to the cap of the electroscope. If it is not charged, the leaf does not diverge. So you just bring the material close to the brass cap, then you just observe the divergence of the leaf. So when the divergence increases or decreases, it means there are charges. But when there is no effect on the divergence of the leaf, it means the material is actually not charged. Now you charge an electroscope negatively by contact method, then slowly bring a negative rod to be tested close to the cap of the electroscope. The leaf diverges more. It does so because the negative charges on the rod repel more charges from the cap to the plate and the leaf. Similar charges in the plate and the leaf always repel each other. Therefore, the leaf divergence increases. Now, when a strong positive rod is brought from high positions towards the negative electroscope, the leaf divergence first decreases, then increases as the rod approaches the cap. Now, the leaf divergence reduces slightly first because the positive charges on the rod attract negative charges on the leaf and the plate, making the electroscope neutral. So on removing the rod much lower, the leaf divergence increases again to higher positions. So this is because the strong positive rod attracts more electrons from the plate and the leaf, making them more positive, hence they are further repelled. So the same observation are made when a negatively charged rod is brought close to the positively charged electroscope. Now remember that on moving a neutral conductor close to the charged electroscope, the leaf divergence decreases. Charges on the electroscope induce opposite charges on the conductor. So the table here is a table which actually summarizes the leaf divergence when positively or negatively charged rod is brought close to the cap. So here we have charge on the electroscope, then charge brought near the cap, then effect on the leaf divergence. So if our electroscope is positively charged, then you bring a positively charged rod, the divergence on the leaf will actually increase. Why? Because positive and positive charges repel each other. So it means the plate is positively charged and also the leaf is positively charged. So because of the increase in the positive and positive charges, so the repulsion between the two positive charges is what increases the divergence of the leaf. When you bring a negatively charged rod close to a negatively charged to the cap of a negatively charged electroscope, the leaf divergence also increases. Why? Because negative and negative charges will always repel each other. However, when you bring a positively charged, this is a charge brought near the cap. When you bring a negatively charged rod onto the brass cap of a positively charged electroscope, the leaf divergence decreases because of the attraction. Because attraction reduces the number of charges. Remember, some of them could also be neutralized. Also, when you bring a charge on the electroscope, if the electroscope is negatively charged, then you bring a positively charged cup, the divergence also reduces because of the attraction between the metal plate and the leaf. Now when you bring an electroscope which is positively or negatively charged, then you bring an uncharged body close to it, the divergence decreases. Why? Because the charges the charges flow to the uncharged body. Then another function of an electroscope is to test the quantity or the amount of charges on a charged body, to test the quantity or the amount of charges on a charged body. So here you use two pith poles coated with aluminium and having different radii are placed on insulating handles. Then they are charged by rubbing with a duster. The charged balls are brought close to the cup of a charged electroscope. So the ball with a smaller radius causes a slight increase in divergence, while a large ball causes a great increase in what? Divergence. So if a body has more charges and is brought close to the cup, the divergence is more. But if a body has lesser charges, the divergence also becomes less. So simply, the amount of divergence is directly proportional to the quantity of charge on a body. So an electroscope can be used to test the quantity of charge or the amount of charge on a charged body. Then an electroscope can also be used to test. It can be used to test the insulation property of a material. It can be used to show you whether a material is charged or is an insulator. Now, materials like copper, iron, aluminium, zinc, and graphite make the leaf divergence decrease. Materials like plastic, those are insulators, plastic, glass, wood, charcoal, do not affect the divergence of the leaf. So for metals and graphite, the leaf decrease in divergence because they allow electrons to flow between the electroscope and the earth. So such materials, we call them conductors. So because conductors allow free flow of electrons, it means they can cause the leaf to reduce because the charges flow away. Therefore, the divergence can reduce. So in conductors, electrons freely move from one atom to another. So such electrons are called free electrons. For materials like plastic, glass, and wood, there is no charge. There is no change in leaf divergence because they do not allow electrons to flow between the electroscope and the earth. Therefore, they will not have an effect on the divergence of the leaf. So in these materials, the electrons are not free to move and they are strongly bound to their nucleus. Such materials, we call them insulators. Then there are other materials like silicon and germanium, which are conductors under special conditions. Sometimes we call them semiconductors. So this conductivity, their conductivity is between the conductivity of insulators and conductors. Such materials, we call them semiconductors. So those are the four uses of an electroscope. 1, to detect presence of charge on a charged body. 2, to test the sign of charge on a charged body. 3, to test the quantity of charge on a charged body. Then lastly, to test the insulation property of a material. Lastly, we look at what we call charges in air. So there can also be charges in air. So air can also be charged. The presence of charges in air can be shown by heating air above a charged electroscope, where it is observed that the electroscope divergence decreases. So when a fuel burns, chemical reactions yield ionized products. The ions move and collide with air molecules, making air to be ionized. Ionization produces both positive and negative charges. The ions carrying opposite charges to the electroscope are attracted to the cup of the electroscope, resulting in the discharge of electroscope. Charges on insulators can be removed by ionized air. Then other than heating, air can also be ionized by use of what? Radiations. Then lastly, we look at applications of electrostatics. One is that electrostatics is applied in electrostatic precipitation. Electrostatic precipitation. Now, air pollution is a serious environmental problem of a global concern. Therefore, heavy industrialization has contributed most to the phenomena. So in an attempt to reduce pollutants, some industries have installed electrostatic what? Precipitators. So here are the common features of an electrostatic precipitator. So the precipitator consists of a cylindrical metal plate. So it is usually cylindrical in shape. It consists of a cylindrical metal plate fixed along the walls of the chimney and a wire mesh. This is what we are calling our wire mesh. Then this is the chimney, the surrounding part through the middle. Then the plate is charged positively. You can see our plate here is positively charged. This one is also positively charged, whereas the mesh is negatively charged. This is our wire mesh. So we are saying that precipitators consist of cylindrical metal plates fixed with along with the walls of the chimney and a wire mesh suspended through the middle. The plate is charged positively at a potential of about 50,000 volts, while the mesh is negatively charged. Therefore, a strong electric field is set up between the plates because one is positively charged while the wire mesh is negatively charged, which ionizes the particles of the pollutants. Now, these are then attracted to the plates. Then the deposits are then removed from the plates occasionally. Then we also apply electrostatics in spray painting, whereby the can is filled with the paint and its nozzle is charged. So during spraying, the paint droplets acquire similar charges and therefore spread out finely due to repulsion. As they approach the metallic body, they induce opposite charges, which in turn attract them to the surface, full stop. So the little paint is therefore used. Then lastly, we look at the dangers or the hazards of electrostatics. So when a liquid flows through a pipe, its molecules becomes charged due to the rubbing on the inner surface of the pipe. If the liquid is inflammable, it can cause sparks and explode. So similarly, explosive liquids carried in plastic cans can get charged due to the rubbing. So this may result in sparking and even explosion. Therefore, it is advisable to store fuels in metal cans so that any charges generated continually leaks out. So we've come to the end of our class today, but we need to discuss the quote of the day, which simply stated that never trust a person who treats you well but disrespects a waiter or a watchman. So the quote simply means that in life we need to treat people equally. Yeah, just because we are not supposed to treat people well because of their status. Just because someone is maybe a teacher, someone is an engineer, someone is a president or even a minister, does not mean that they are more human than the person who is holding lower ranks in the society. For example, we have a waiter and even a watchman. I'll give you an example. A story goes this way, that there was a certain man who attended an interview. When he was entering the interview room, he got a watchman on the gate. Then he mistreated or disrespected the watchman, only to go to the interview room and find that the watchman was actually the person to interview that person. Yeah, he was the interviewee, the person, he was among the panel which was interviewing those people. So you see, if the person actually if he had respected the watchman, he could easily get the job, but he ended up not getting the job because he initially disrespected the watchman. So do not just disrespect someone because of their status in the society. Yeah, just because someone has no higher academic qualifications or is not in a well-paying job does not mean he's lesser human. And remember this: if you are helping someone, because you know that they might help you in future, that is not kindness, that is an investment. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.